And repeat this once again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. And with that, we're going to continue with section 3 or 6.3 today. We'll start off answering questions that you have from yesterday, and then we'll look at another method of factoring trinomials with a leading coefficient other than a1. So with that said, do you have any questions? Awkward silence. Everybody's good? Okay, then I will go on. So the method that we looked at yesterday was called grouping, or I had my ABCPS name that I gave it. Today, the method that we're going to look at is called, and I'm looking it up because different books have different names for it. This book calls it trial and check method. I've heard it called guess and check. I've heard it called FOIL. Anyway, this book refers to it as trial and check method. Okay, so the goal is the same, to get a trinomial that's completely factored. And we'll start out the same in that we'll take a trinomial, we'll make sure it's in standard form, descending powers of the variable. If there's any greatest common factor, we'll take that out. But then what we've got left, how we deal with that is what's going to be different today. And again, the reason I'm showing you these two methods is so that you can pick whichever one you prefer and master that method. All right. So, first question, or first example, let's take 3x squared plus 4x plus 1. And I believe I may have even done this one yesterday, the other method, doesn't matter. So here we have a trinomial. It's in standard form, descending powers of the variable. There's no greatest common factor we can take out first, but the leading coefficient is not a 1. All right, so now what we're going to do, we're going to look at the leading coefficient and the final coefficient. Okay, with the leading coefficient, the 3, we're going to create all of the factor pairs that multiplied together give you 3. And in this case, it would just be a 3 and a 1. Not a whole lot of possibilities there. Then we're going to look at all the factor pairs that would give you the final term. In this case, the constant coefficient, which is a 1. So it's going to be a 1 and a 1. And finally, since it's got a plus sign here and a plus sign there, we know that our numbers, the 1 and 1, need to be positive. All right, so now we need to take these two numbers and put them up front, and these two numbers and put them at the end, or at the rear. Since these two numbers are identical, it doesn't really matter which one we put where, and we see that they both would have to be plus. Now, I don't really need this 1 here. I just put it there to show where it came from. But there's your answer. 3x squared plus 3x plus 1x is 4x plus 1. Now, doing this problem, this method, was quicker than using factoring by grouping. What you'll find is that the problems that don't have a lot of combinations, this method is quicker. The problems that have a lot of combinations, the other method might be quicker. So ideally, I suppose, you'd want to master them both. But for now, I would say when we get done here and after today's assignment, to focus on one of them and master it really well before you worry about knowing the other method. All right. Any questions about this problem? Okay. New example. 15a squared minus 28a plus 5. So here we have a trinomial in standard form, that is descending powers of a. There is no greatest common factor that I can take out, and the leading coefficient is something other than a 1. So I'm going to look at the 15, the leading coefficient, and create all the factor pairs that multiplied give you 15. So 15 and 1, 5 and 3. Then I'm going to look at all the factor pairs whose product is 5. 5 and 1. But wait a minute. Our middle term is negative, so that means these two numbers need to both be negative to get a positive product and a negative sum. Okay? Now, there's only one pair of numbers whose product is 5, but also gives us a negative in the middle. But I'm going to look at all the possible combinations now. So this is where we get into this trial and check kind of thing. So I could have a 15a and a 1a referring to these, and I could have a -5 and a -1 referring to these. But I could also have a 15a and a 1a, and the -1 could go there and the -5 could go there. So you see how I switched them around. But I could also have a 5a and a 3a and a -5 and a -1, or a 5a and a 3a and a -1 and a -5. So what I've done is I've taken every combination of these with these, in this case just 2, and every combination of these and these, in which case there were 2. So there are 4 possible solutions. All of these pairs of binomials, if I were to FOIL them together, they would all give me 15a squared at the beginning and +5 at the end. So the key is which combination gives me -28a in the middle. Where does the middle come from? It comes from the outside and the inside. This would be -15a -5a, that's -20a, that's not correct. This would be -75a -1a, that's -76a, that's not correct. This would be -5, oops, I won't work there, -5a -15a, which would be -20a. And this would be -25a -3a, -28a. So there it is, there's the correct one. Now, I did not deliberately put the correct answer last, it just turned out that way. So there's no conspiracy here, sorry. But there is my correct answer, okay? So sort of the trial and check, I wrote down all the possibilities and checked to find the correct answer. Any questions on this problem? Okay, let's take a look at another example. 4b squared plus 15bc minus 4c squared. Okay. So I've got a trinomial that's in standard form in terms of the variable b. There's no greatest common factor, and it has a leading coefficient other than a 1. So I'm going to write out the factor pairs of 4, which is 4 and 1, and 2 and 2. I'm going to write out the factor pairs of -4. Well, let's see. I've got a negative, so it's got to be one positive and one negative. So it could be -4 and 1, -2 and 2, -1 and 4, 2 and -2. But actually, can you see that those are basically the same? So I'm going to go back here and get rid of one of those. Okay. So here's all my possibilities. I could have a 4b and a 1b and a -4 and a +1. Oh, but I've got c's there at the end, don't I? Okay. Or I could have a 4b and a 1b and a +1c and a -4c. So again, I'm taking every combination of these with those. All right. Now I'm going to take the combination of those with those. So I've got 4b and 1b, -2 and +2, 4b and 1b plus 2, and minus 2. All right, now I've got the combinations of those with those, which is 4b, 1b, minus 1 plus 4, 4b, 1b, plus 4 minus 1. So there's 6 combinations, and I'm only halfway done with my possibilities. I haven't considered that with those. Okay, 2b, 2b, minus 4 plus 1, 2b, 2b plus 1 minus 4. Oh, actually, since these two numbers are the same, switching these around doesn't really give us a different possibility. So that's really the same as the previous one. Okay. Nope, nope, nope. So I've also got what? 2b and 2b minus 2 plus 2. Switching it around is going to give us the same result. 2b, 2b minus 1 plus 4. So I've got, let's see, 9 possibilities. Now, every one of these, if I FOILed them together, would give me 4b squared at the beginning. Oh, you know what? I left out the c's here, didn't I? Oh, yeah. Oh. Okay. That one's not very clear. All right. Everyone is going to have a 4b squared up front and a minus 4c at the end. But I'm looking for a plus 15bc, and that's going to come from the middle. So, or rather from the outer and the inner. So this would be what? 4bc minus 4bc. That would just be 0. Negative 16bc plus 1bc would be minus 15bc. Right number, wrong sign. 8bc minus 2bc is 6bc. Negative 8bc plus 2bc is what? Negative 6bc. 16bc minus bc. Oh, there we go. Let's double check that. 4b minus 1c, b plus 4c. I just got rid of those ones because they're implied anyway. In other words, if I don't have it in front of the variable, it's still implied 1. This is what? 4b squared plus 16bc minus bc minus 4c squared, 4b b squared plus 15bc minus 4c squared. So there you go. Now, that sure seemed like a lot of work. And it is if for you to come up with a 15bc, you're going to have to write all these combinations. And I suppose what you could do is you could write one and check it and write one and check it. And then, you know, you'd get down here and you wouldn't end up writing all the rest of them. But to use this method really efficiently, you want to be able to do all the little multiplications in your head. If you can do that, then this method generally is quicker than grouping. If you can't, if you need to write them all out, then it's not necessarily more or faster, especially when you've got a lot of different combinations here. So what do I mean by doing it all in your head? Okay, well, let's go back and let's look at our original combinations. In fact, I think what I need to do is copy this over. 4b squared, let's see here, plus 15bc minus 4c squared. And we had a 4 and a 1 and a 2 and a 2 and a negative 4 and a 1 and a negative 2 and a 2 and a negative 1 and a 4. I think that's right. Yeah, okay. Now, when I write those out in factored form, and then I start to FOIL them together, what I end up doing is taking one of these times one of those, plus the other of those times the other of those. That's sort of that outer inner. Okay, so 4 times negative 4 is negative 16. 1 times 1 is 1. And then I add them. Negative 16 plus 1 is negative 15. Okay, now I got the right number but the wrong sign. But now I've got to switch them around. I've got to take the 4 times the 1 and the 1 times the negative 4. 4 times 1 is 4. 1 times negative 4 is negative 4. 4 plus negative 4 is 0, not 16. Okay, so let's take this group with this one. 4 times 2 is 8. 1 times negative 2 is negative 2. 8 plus negative 2 is 6. That didn't work. Switch them around. 4 times negative 2 is negative 8. 1 times 2 is 2. Negative 8 plus 2 is negative 6. That didn't work. This one times this one. 4 times 4 is 16. 1 times negative 1 is negative 1. 16 plus negative 1 is 15. Aha. So here's our combination. So let's see, I've got a 4b and 1b from here. And then let's see, I took the 4 times the 4. So would I put the 4 here? No, I'd put it over here, wouldn't I? So I'd have the 16b minus 1b. Oh, but I still need the c's, don't I? All right. Now, I don't know if you followed that. I kind of went through it quickly because if you're going to do it this method, a problem with this many possibilities, you're going to want to be able to do those little multiplications. So you take this times this, plus this times the other one, and then you add them, switch them around and try it. Okay? So when there's a lot of combinations, this kind of problem can be lengthy, especially if you write them all out. But if you can do the little things in your head, this is a great method. So what tends to happen is people that can do all those little things in their head prefer this method. People that can't tend to prefer the grouping method. Anyway, let's take a look at another example of this. Let's see here. How about this one? 4a squared minus 15ab plus 9b squared. So I'm going to have a 4 and a 1, a 2 and a 2. Oh, this is positive, but this is negative, so they're going to have to both be negative, aren't they? All right. So I'm looking for a negative 15 in the middle. 4 times negative 9 is negative 36. 1 times negative 1 is negative 1. Negative 36 plus negative 1 is negative 37. So that didn't work. Okay. 4 times negative 1 is negative 4. 1 times negative 9 is negative 9. Negative 4 plus negative 9 is negative 13. So that didn't work. All right. So now I'm going to take this pair with this pair. 4 times negative 3 is negative 12. 1 times negative 3 is negative 3. Oh, negative 3 and negative 12 is negative 15. We have a winner on aisle 7. So 4a, 1a, minus 3b, minus 3b. Let's see if that works. 4a squared minus 12ab minus 3ab would be minus 15ab plus 9b squared. So it works. So again, doing it this way, not writing out all the combinations, this method, not too bad. All right, questions on that one? Let's take a look at another one. 16r minus 40r squared plus 25r cubed. This trinomial is not in standard form, so let's put it there. And there is also a greatest common factor of an r. So we're going to get r times 25r squared minus 40r plus 16. So I've got that r that I factored out that's going to be in my final answer, but now my focus is on the parentheses. And 25 could be 25 and 1 or 5 and 5. 16, well, it's a plus 16, which means they both have to be positive or both negative, but it's a negative middle one. So I'm going to have two negatives, negative 16 and negative 1, negative 8 and negative 2, negative 4 and negative 4. All right, now let's see. I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 7, 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there would be about 10 different possibilities, maybe more, if I wrote them all out. But I'm just going to look for negative 40. Okay, so 25 times negative 16, that would be negative 400. 1 times negative 1 is negative 1. Negative 400 plus negative 1 is not negative 40, right? Okay, let's switch them out. Let's take 25 times negative 1 is negative 25. 1 times negative 16 is negative 16. Negative 25 plus negative 16 is negative 41, close but not correct. Okay. So now let's deal with this set and this set. 25 times negative 8 is negative, what, 200? And 1 times negative 2 is negative 2. Negative 200 plus negative 2 is not negative 40. Let's switch them out. 25 times negative 2 is negative 50. 1 times negative 8 is negative 8. Negative 50 plus negative 8 is negative 58. Are you able to follow this, or am I just rambling on here?
My personal opinion is it makes sense. I just feel like it's more work, in my opinion. I feel like the other way would be easier, but I definitely understand your point of view on this way.
Okay. Now, I am biased. I prefer the other method, but the department said that we need to introduce both methods, so I'm doing it. Trying not to show my bias, but trying to show you that this can get really extreme, but if there's simpler problems, this method's quicker, but this kind, not so. All right, well, let's keep going. Okay, let's see. 25 times negative 4 is negative 100. 1 times negative 4 is negative 4. Negative 100 plus negative 4 is negative 104. But if I switch these two around, I'm going to get the same result. So basically, the 25 and the 1 are out. Okay, so I'm going to recopy this using just the 5 and the 5. Okay, because we've already determined that the 25 and the 1 don't work. All right, so 5 times negative 16 is negative 80. 5 times negative 1 is negative 5. Negative 80 plus negative 5 is negative 85. Now, since these two numbers are identical, if I switch them around, I'm going to get the same result. Okay, so that didn't work. Let's take these two. 5 times negative 8 is negative 40. 5 times negative 2 is negative 10. Negative 40 plus negative 10 is negative 50. Switching them, we'd get the same result. Here we go. 5 times negative 4 is negative 20. 5 times negative 4 is negative 20. So I've got to have a 5R and a 5R and a minus 4 and a minus 4. Don't forget that R outside. So I end up getting that, which, as we talked about yesterday, could also be written that way. Okay. And I have one more example I'm going to torture you with. So here we go. One of my colleagues, as he was retiring, he said he could have been a dentist, but then he only could have tortured one student at a time. This way, you know, I can do the masses. So, okay. So here's a trinomial. It's in standard form, descending powers of u, no greatest common factor, leading coefficient is not a 1. 10 is what? 10 and 1, 5 and 2. Negative 6, since it's negative, we've got to have a negative 6 and 1, negative 1 and positive 6, negative 3 and 2, negative 2 and 3. So we've got what? 16 possibilities. Okay? And I'm looking for a negative 13. So here we go. 10 times negative 6 is negative 60. 1 times 1 is 1. Negative 60 plus 1 is negative 59. That didn't work. 10 times 1 is 10. 1 times negative 6 is negative 6. 10 plus negative 6 is 4. That didn't work. 10 times negative 1 is negative 10. 1 times 6 is 6. That's going to give us a negative 4. That didn't work. 10 times 6 is 60. 1 times negative 1 is negative 1 plus a negative 1. That's 59. Notice I'm getting the same products, just different signs. That didn't work. Okay, 10 and 1 in the negative 3 and 2. 10 times negative 3 is negative 30. 1 times 2 is 2. That's negative 28. 10 times 2 is 20. 1 times negative 3 is negative 3. That's 17. Now, that didn't work. Let's see here. Have I skipped something? 10 times, I feel like I skipped over something. Maybe not. Let's see. 10 times negative 2 would be negative 20. 1 times 3 would be plus 3. That's negative 17. And then 10 times negative 2. Oh, no. I just feel like I missed one there. Maybe not. Let's see. I did the 10 and the negative 6. And the 10 and the, you know what? Part of the problem is I can't even read my numbers anymore because they're so messy. And let's see, negative 6 and 1, negative 1 and 6, negative 3 and 2, negative 2 and 3. Let's see, I did negative 60 and 1. I did 10 and negative 6. Okay. I did negative 10 and 6. 60 and negative 1. The problem is you can't see my hands here. I did negative 30 and 2, and 5 and negative 12 is the one I left out. 5, negative 12, which is negative 7. Okay. And then, let's see. Okay. Negative 30 and 2, 5 and negative 12. Then I've got negative 5 and 12, and 30 and negative 2. So I get 28. Again, I'm getting the same numbers, but different signs. None of those are working. Here. 5 and negative 3 is negative 15, and 2 is 4. No, that's still not right. How about 10 and negative 6? No, that's not right. Negative 10 and 6, that's not right. Negative 15. None of them are working. That was awful, wasn't it? I got confused, and I'm the teacher. There were just so many combinations there, I kind of lost track of them. But it was prime. Might have been better if I'd gone ahead and written them all out, but that would have taken forever. But again, this method can be really nice. Like the very first problem I did, quick and easy. This problem, awful. So in reality, me personally, if I have something like this problem, I'm probably going to use this method because I'm going to see that, it's got to be a 3x, it's got to be an x, it's got to be a 1, it's got to be a 1. Those are the only combinations, and I'm done. But if I've got something like this, where it's more complicated, I most likely would go back and use grouping. That's just my own personal opinion. Again, so tonight's assignment, regardless of whether you want to go back to the other method, I want you to practice using this method. Now, WebAssign isn't going to know the difference because all you're going to do is put in your answer there. So it's up to you. I really want you to try this method, even if you're thinking, this is awful. Because some of you that think it's awful will try it and decide that you like it. Others of you will conclude that, yeah, you were right in the first place. You didn't like it. But try it. See what happens, okay? All right. I'm done with you unless you have any other questions. Okay, I'll be back at 1:15 with an office hour if you want to join the Zoom meeting, or I'll periodically be checking my emails. But have a good rest of the day, and I'm going to stop the recording.